chair. Okay. So 11.5, let me see. Let me start off with this. If I had a number, let me just say, if I had a number times a number is greater than 0. Just think about it for a second. How do I make the product of two numbers? And what's greater than 0 really mean? What's a quicker way to say that? Positive. You guys with me? So if it's related to 0 with an inequality, it's really saying positive or negative, basically. Is that cool? So how do I multiply two numbers and make sure they come out to be positive? What's got to be true? They both have to be positive. Or, alright, now in writing that down, I would not want to do this problem. Can you imagine if I add one more number in there? The number of cases you have to look at? Right? So there's a better way to do this, but I just want to eliminate this. So if I wanted this to be positive, is everybody cool with what's happening up here? Is that cool? If that's true, or that's true. If they're both positive, the product is positive. If they're both negative, the product is positive. Is that cool? This is the case that people would not realize, because if you look at each piece of it, it doesn't make a damn bit of sense. But if they're both negative, of course it's going to come out positive. But people forget about this case. Right? Now imagine this. I'm not even going to write it all out. Because, good God. How do I make that positive? Yeah, they could all be positive. Or A less than 0 and B less than 0 and C greater than 0. Or A less than 0 and B greater than 0. And oh, do you understand what's happening? Yeah. Good God, Jeff. Shit. All right, there's a much better way. I'm going to tell you real kind of quick. This is nothing you're held to because it's bonus. It's extra credit. But I want to expose you to this idea because it's really powerful. So instead of doing cases, I just directly analyze when is this thing positive, when is it negative, because that's exactly what the question is asking. So for example, if I said, well, let me start off not too freaky. All right. I think I'll just do a couple of examples. So I don't freak out too much, but try to see how this kind of makes sense. Let me see. Now, what's the dividing line between positive and negative?
0.
0. I love it. So it's all about what side of 0 are you on. So 0 kind of factors into this. When is this expression equal to 0? At what points is it equal 0? At 2, negative 3, negative 5. Is that cool? So it's 0 here, it's 0 here, and it's 0 here. All right, so what I'm going to do, instead of doing all those different cases, I'm going to look at the whole thing at once. And I'm going to say, all right, well, it's 0 at these places. So on either side of it, it's got to be positive or negative. Does that make sense? If you're not 0, you have to be positive or negative. Is that cool? And is this 0 anywhere else than those three places? No. So everywhere else has got to be. And really, I know I'm not giving this all the credit it needs, but what can I do? If it's positive, what's the only way it could become negative? This is like the graph of a function. What's the only way it could become negative if it goes through 0, right? If it goes through 0. Do you guys see what I'm saying? So that's why, now watch what I can do. In here, it's got to be all positive or all negative, because the only way it can change is to go through 0. So it's either going to be all positive in here, meaning in between negative 3 and 2, it's going to be above the x-axis. Yes, sir?
Shouldn't that be greater than or equal to 0?
No. My answer will not include these because that's where this equals 0. Is that cool? So if it was greater than or equal to, these would be part of my answer. At the end, these will not be part of my answer. Because what do they make this do? Equal 0. And is that what it asks for? No. It just wants to know where is it positive. Now, stay with me now. This is almost too easy to believe, even though right now you're like, that phrase doesn't belong in this discussion. But watch. Give me a number between those.
1.
The best number between those. 0. Yeah. I always do 0. Good Lord. if I plug this in and the answer is positive, that means every number I could pick between there is going to come out positive, because the only way it becomes negative is if it goes through 0. These are like doors from one side to the other. So if I plug a 0 in, what do I get? Negative times positive times positive. And what is that?
Negative.
Negative. So in here, it's negative. Through that whole place, if you pick any number between -3 and 2, it's going to come out negative. It has to. Do you guys see that? So if at 0, it's down here, and it's 0 at 2, and it's 0 at -3, could it be up here anywhere in there? No, because if it's not, the only way you can get through is through these doors. So it can only become positive after 2. It can only become positive after -3. So all you do then, this kind of is nice. Where is it 0? Then you check each region out. Now go with me for a little bit. So what do I do over here? Plug in what?
3.
1's over here, right? Be careful. 3 is over here. So if I plug in 3, what do I get?
1.
So this is 0. Plug in 3, I get positive. I don't even care what the number is. In fact, very often I'll say, I'm going to plug in 18 billion. Because isn't that in there too?
Yeah.
Okay, I don't care what the number is. I don't give a shit what the number is. I just care, is it positive or negative? So if I plug in a 3, I get positive, positive, positive. Which of course is positive. So it's positive forever up there. What about in here? What could I use?
-4.
-4. When I plug a -4 in, what do I get?
-6.
I get negative.
Positive.
Get out of there. -4 plus 3 is negative,
Positive.
and that's positive. I like it. Negative times positive is positive. Somebody give a guess as to what this is going to be?
Negative.
Beautiful guess, and you're right. If you plug a -6 in, you'll get negative times negative times negative comes out negative. So everything I just did, was it really hard computationally? No. Where is it equal to 0? Well, it's already factored, so I can see exactly where it equals 0. Then you just plug in numbers in those regions, and you see what they are. Yes, sir?
So how will the answer to this question work?
Beautiful. That's where we are now. I love that. So this question is asking, where is this?
Greater than 0.
No, don't read this. Tell me what this means. Where is this? Positive. Where is the positive?
-4.
Between -5 and -3. And how would I write that considering what Nathan said? There is no equal sign here, so would I include this? Parentheses. Because it's positive here, right? Or?
2 and infinity.
2 to infinity. I like it. Done. Right? Remember, this is an A, B, C. How many cases would there have been to check out if I would have wanted to do it? Too many. Right? Too freaking many. So I just attacked the damn thing head on. This is how you do these. This is how you do it. So even if it would have been, I'm not going to do this, but let me see if you guys can see what I mean. This would have had the same exact work. The exact same work. The exact same work, except what do you think I would put above -5? Doesn't make it 0, makes it... What does -5 do to it? Makes it what? Undefined. I put a little U, dude. Is that ever going to be an answer? I don't care what the hell the grade and their grade equal. If it's a U, it's not going to be part of the answer. All the work would have been exactly the same. Do you guys see why? Negative times negative is the same as negative divided by negative. So this work would look just like this, except there would have been a U here. Because it's undefined. It would have the exact same answer. Again, this is extra credit. But you get the basic idea of this. I mean, this is a really powerful tool. And to be honest, this section doesn't even go this far. Right? This section just says, what if I have a parabola? If I have an up parabola, where is it always going to be negative? If it's going to be negative, where is it going to be negative?
Below 0.
But what are these? What are these? X-intercept. So where is a up parabola ever going to be negative if it is? In between the x-intercepts. Yeah. Right? So there's a shortcut if I'm just dealing with parabolas for this problem. That's almost too easy to talk about, to be honest. If it's a down parabola, it's going to be what between its intercepts? Positive. Do you see what I'm saying? So if I said x squared minus 4x, what do you got, Jeff? Plus 3 less than or equal to 0. Is that up or down? Up. So if I find the intercepts, the answer is going to be, I want it to be less than 0, so what's the answer going to be? If I find the intercepts, the answer is going to be between those. What are the intercepts for this? How do you factor this? I like it. So it's like 1 and 3, right? That's a little side work. Do you guys follow what I'm saying? So I don't even have to do this because I know what it's going to look like graphically. So what's the answer to the question? Then when is it less than or equal to 0 from 1 to 3? If the question was where is it greater than 0, it would have been below 1 or above 3. All right, I like it. So when it's quadratic, when it's parabolic, this question is stupid easy. I don't have to do any of this shit. But the minute I put one more term on there, oh my God, I want this to exist so I can do it this way.
But this chapter doesn't have this equations.
No, this chapter actually only has these.
Oh.
To me, this is a much better skill to have. So when you get to, if any of you are going to pre-calculus, you will definitely do quite a bit of this. Okay, cool. Quite a bit. So that's section 11.5. Again, that's extra credit. You could do it or not. 11.6, very quickly, let me make sure. That's right. Okay. So again, look at this. How would I solve this again? How would I solve this? It's crazy. So the answers are?
1.
All right, that's number 1. Now here's 11.6. Here's what 11.6 says. That's nice. How would you solve this? And you say, I probably would do the same thing. Right. Now there's a method you could use, but to me, personally, I think the method is too much for this. But the method you could use is U substitution method. If you let U equal x squared, what's U squared? X to the 4th. Is everybody kind of cool with that? So then I can write this to look like U squared minus 4U plus 3 equals 0. And that looks just like this.
Did you just pick U out of like...
U is kind of like the standard letter to use for substitution. U substitution is a very commonly used phrase through calculus and beyond. Yeah. You'll use the letter U to replace a part that you're like, that looks gross. Let me replace it with U and see if it looks better. You guys semi with me now? No, yes? Isn't this true? If U is x squared, isn't this true?
Yeah.
Now, I love it. A lot of you guys are like, what lets you do that? Well, what let me use the letter x in the first place? Because it was a number I didn't know. Well, what is x squared? What's x squared? Tell me.
X and X.
Beautiful. But what is it? Tell me. Be more specific. What is it? I don't know. So let me call it U. Anything I don't know in algebra, I can call it a letter. I know that feels like cheating on some level, and I actually don't care, because it isn't. That's the whole underlying premise. I want to do something with it. Let me give it a letter name. So x squared is something I don't know. Let me call it U. So the x to the 4th must be U squared. That looks much easier. How do you factor that? Like that. So what's U? U is 1 or U is 3. But I like it. What is U? What do U be? X squared. So x squared is 1 or x squared is 3. So then x is plus or minus 1, or x is plus or minus rad 3. Again, you really shouldn't need to do U sub, but this is the way the book shows you. Why should you not need to use U sub? Because how do you break x to the 4th up? X squared. Factors of 3, minus 3 minus 1. Equals 0. Set each of these equal to 0, and then you can use the square root property. You don't need U sub. But if you kind of like U sub, I actually don't mind, because it's something that's used a lot later when things get really worse. In fact, I think there's a bonus problem on the first test that was like factor this disgusting looking thing, and you can use USEP to make that work better. Okay. And you're all like, dude, I can barely remember this morning. So, all right. So that's section 11.6 is, and can somebody, I've said this a few times in this class, what told me this should work? Why should this work? Because what's true about the powers, what's got to be true about the powers? The middle one has to be half. So if that was a 6, this better be a 3. So that's what they mean by quadratic in form. The middle power is half the first power. That's what tells me it's going to work like this. If it wasn't, it might work, but it's not going to work like this. It's going to work in a much worse way. Maybe synthetic division. All right. All right, so that was all bonus. So if you don't want to do 11.5, 11.6, if you're going to go into pre-calculus, you might want to give it a try. Just so you have a little heads up what is in your future. 11.5, 11.6. They're both officially now extra credit. So I'll get that up on, whatchamacallit, My Math Lab later today. I got the 11.5 up there, but, or do I? Maybe not.
No, we don't.
I like that, right? He's like, no, you don't. All right, I'll get them both up there. Yes?
Can you, like x being 6?
Oh, you mean like if it would have been this?
Yeah. We have a 6 answer?
Yeah, you should get 6 answers. Officially, you should. I can't remember the book actually gets all 6 of them. Because you'll get like little difference of cubes or sum of cubes, which you should be able to factor. Remember, there's that problem on the test that was like this, and I thought maybe I'd get some questions about this. Because if you got, like on this problem, you got 4, you're like, what the hell's wrong with that, dude? What the hell is wrong with that? Well, the main thing that's wrong with it is you're supposed to get 3 answers. So if you don't get 3 answers at this point, you know you're wrong. The only reason we didn't get 3 answers for this before was because we didn't know about complex numbers. Now that you know about complex numbers, when you see a 6th power on a problem, you're supposed to get 6 answers. If you see a 3rd power, you're supposed to get 3 answers. If you don't, you did something wrong, or you didn't do enough. So the right way to do this problem was to bring that over, factor. This one you need quadratic formula for, and that's where your complex numbers come from. So we did a problem like that in class before. Cool. All right. So let me do that. I'm going to do a little bit of stuff from chapter 12, and then we'll take a break. All right, so here comes the stuff you're actually responsible for. Oh, and, well, shoot. So we have the little, I don't think I have any more. Their updated homework sheet. Yeah, I think I gave all mine away. Yeah, let me just look at it for a second. Cool, all right. Yeah, so when you go to do section 11.6, you do the updated version for the extra credit, because I cut back on the numbers. Cool. Okay. So, all right. The beginning of section 12 is kind of nice because I kind of prepped you for this already. Let me see if you guys catch my meaning. If I said f of x is 2x squared minus 1, g of x is 5 minus x. All right, let's just all remember how functions work. What is f of negative 2?
2 negative 2 squared.
Just take a second and figure it out. you know, a little more than a second maybe. Don't say anything out loud. Say again. So let's see. So what do I do with it? I write this, but instead of x, I write in parentheses the thing, right? 2 times negative 2 squared, because I have to square x, so I got to square negative 2 minus 1. So 2x squared minus 1. Twice this thing squared minus 1. All right, just plug in check. And of course here, what do I have to do first? Yeah, square negative 2, you get 4. 8 minus 1, 7. Okay, I like it. Don't do negative 4 squared is 16. That's crazy. That's PEMDAS. You're completely breaking that. All right, put you in math jail or something. So what about let's see. What's G of W?
X minus W.
5 minus W.
5.
All right, I like it. So, what is f of 5 minus x? Take a minute and try to figure that out. What's f of 5 minus x? You guys can do it. And this is, again, the process doesn't care what's in there. It just says whatever's in there, put it in. And then we have to simplify it. So, you know, like here, if I would have said G of A, it would have been 5 minus A. If I would have said G of L, it would have been 5 minus L. If I would have said G of Jeff, it would have been 5 minus Jeff. So it doesn't, don't focus too much on the fact, I know that 5 minus X is, but what is f of 5 minus X? You take this, and you put it in place of, what was it, plus minus 1? Wherever the X is, I replace it with what this is. So twice something squared minus 1, so twice that thing squared minus 1. That's the first step. And now you just simplify that. And of course, what do I always have to do first? For the f function, I have to... Well, what do I do first in here?
Exponents.
But yes, exactly. You got to square first, right? So I get twice 25 minus 5 minus 5 minus 10x. Is that cool? Plus, is everybody cool that what's happening? Just FOIL that bad boy out, right? Write it twice. 25 minus 5x is minus 10x. Negative x times negative x is, I love it. So what did we do first here? We squared negative 2. Then we took that and we multiplied by 2. Okay, I take that and I multiply by 2. 50. So then I finally get 49 minus 20. I like it. If you want to, you can turn that around and put it in descending order. 2x squared minus 20x plus 49, take gas. All right, nothing major. All the stuff involved, all the math involved in calculating that should be stuff we can all handle. Easy stuff. The slightly, it's not even new. This idea is not even new. But can anybody see, why did I pick 5 minus x specifically? Now I want you to notice this. Why did I pick 5 minus x? Because it's actually what?
G.
It's actually G. So what's another, I could say, what is f of g of x? That would be the real question. What's f of g of x? Well, I'd say, what the hell's g of x? Oh, it's 5 minus x. They want me to plug 5 minus x into f. So it wouldn't start there. That's not that bad. It would start there. And the first thing you say is, well, what the shit is this? Oh, it's that. Oh, that's what they want me to plug into f. Okay, no big deal. So this is what we call composition of functions. Right? The result is composed of this inside of this. So that's why they call it composition. Unfortunately, they use the stupidest notation they could think of. I don't know if it was a contest gone wrong. What's the dumbest way to do this? And then they went, all right, let's do it that way. So the way that we represent this is using this notation. Yes, what students feel like they're in sometimes. That is just dumb. You know, I have no qualms in saying that. So in history somewhere this was thought to be a great way to represent this. Why not just write what it really freaking means, right? This doesn't show me that G is inside of F, does it? This, I can see G is in F. That's what this means. So if you saw this, how do I really think of that? So what's inside of what? F is inside of G. I like it. You guys with me a little bit? A little tiny bit? Not really? Screw you, Jeff. Alright. I like, well, yeah, that's where I start. Alright, so let me give you guys a few to try. I will use this notation so you're not that freaked out when you get to the book. So, let's say f of x is the square root of x minus 2. And g of x is x squared plus 5. So what is g of f of x? And what is f of g of x? We'll do those two first, and then we'll do a freakier one. Did anybody come in after I gave out the test? Anybody need their test still? Okay. As you told me.
Mm-hmm.